अभी राजेश जी नहीं है, हाँ ठीक है. Welcome you all. Myself MP Mishra, faculty, School of Computer and Information Sciences. In this session I am with you on a topic related to BCA third semester course, that is programming in C++. In this session I will discuss you with one important aspect, that is objects, class and inheritance in C++ programming. Basically, when we talk about C++ programming, if you remember in the previous session I discussed about basics of C++ programming. Basically, I covered first block and I introduced you the concepts of object oriented programming and its advantages. So, in continuation of that, this session is planned, and in this session we will be discussing about that how actually objects and classes are created in C++ programming, how actually we will do our program or write our program, and what is the concept of inheritance. If we are using concept of inheritance, then what is advantage of it. So, basically around this we will discuss in this session, and in this session we will see in next page if we go, there is a technical glitch. I think just my technical team will make a correction, then I will proceed further, because slide is there is some technical problem, so just please wait. Okay. So, now let me come to our actual topic. In fact, there are few things, because we are making effort to reach to you with the some kind of makeshift arrangement. As you know, due to lockdown, several things are not in place, and we are making some arrangement. Through that we are trying to reach. So, sometimes some technical glitches comes, and sometimes some kind of modification or alteration we have to do. So, I request you to bear with us. We will try our level best to reach to you and provide you some kind of learning environment and some kind of learning discussions, activities and classes and sessions. So, with this, let me come to our point and start afresh. So, from this point onward, I am discussing the content of this session. So, in this session we will discuss around what actually object is, what class is, what is constructor, and then we will discuss about inheritance, and if time permits I will discuss about the concept of polymorphism, and in that sense I will try to introduce the mechanism of function overloading and function overriding. So, as far as an object is concerned, as you can see in your study material as well as in previous session also, I gave lot of emphasis about developing the conceptual understanding about the object, because whenever we are going to do programming with the help of object oriented concepts or using features of object orientation, then it is very essential for us to understand that what actually object is and what are the different objects in our system that is going to help us to make our program. So in that context, identification of object in a specific programming context or in a specific problem solving situation is very important for us. But as a basic learner of the object oriented technology or object oriented programming concepts, you have to just identify few objects, create program for that, and then use those objects for solving specific problems. So if you take object around you, you will find that there are many objects which are used for different context, in different contexts for different kind of problem solving, and few example of that may be the student object, then account object. If you are dealing in a system in which some sales and purchase or some kind of selection of different items is happening, then in that context item object. Similarly, many more objects. If you are dealing with, let us say, some library system, then there are again different kind of object. For example, maybe books, journals, magazines, maybe the librarian or maybe the person who is issuing the book and getting the books returned from you. So you will find that there are different objects and they are having their well defined role in the system. And as far as overall functioning of any system is concerned, so these objects communicate with each other with the help of message passing, and that message passing happen with the services that those different objects provide. It means if a object is there, that object is supposed to perform some operation, and those operations are termed as different kind of services associated with those different objects. This will be little more clear when we will discuss with the help of some example. So now let us move forward and try to be little more specific towards what actually operation means. In object oriented context, when we say there is a object, so that object is having certain attribute and certain operation, and those operations sometimes work on those attributes, or those operations provide some kind of information to another object to perform some more activity on the basis of that. So different objects in some order communicate to each other. Maybe some objects are working parallelly in a system, maybe some objects are working serially in a system. So how actually those different objects at different moment of time are participating in the solution process, that you have to design as a programmer, and that you have to use in your specific problem solving context. For example, again, if we take a system in which students objects are playing different roles, so what kind of different role may be? If a student object is there, that object is supposed to register in the program, that object is supposed to participate in teaching learning process, maybe attending classes, maybe doing some exercises, maybe participating in discussion forum if you are talking about some student object in online learning environment. Similarly, there are some other objects also who are participating simultaneously. For example, teacher object. So teacher object is delivering the lecture and student object is listening the lecture. Similarly, in discussion forum, one student object is posting some message or information, maybe other student object are reading those comments or input in discussion forum and reacting to it. So there are different roles assigned to different object, and in combination those all different roles are used to perform the operation. So until unless we visualize the system in that context, it is very difficult to handle a complex situation. For simple system, definitely you can identify one or two classes, you can create one or two objects and use those objects to perform the operation. So basically that will be a kind of learning process at the early stage or basic stage, but gradually you have to move forward to think in terms of some complex system in which there are different objects and those different objects are participating in the system to perform different operations. Now operations are generally categorized in three categories. As you can see on your screen, it is listed: manager, modifier and selector. So manager object is supposed to perform initialization and cleaning up operation. So those methods, basically here you can associate this operation with methods, because ultimately when you say service operation of a specific object, so at the time of implementation you are implementing the specific method. So that manager method is nothing but the constructor. I will touch upon the concept of constructor and I will try to show one example that how actually you define constructor in C++ and how you use that particular constructor. And then modifier, basically whenever we are having any problem, so in that problem we are going to write certain code to perform different kind of operation to achieve our goal. So those different codes are basically categorized as per the specific activities or services identified, and those codes written to perform certain operation come under modifier category. So another kind of method will be modifier. For example, if we are having, let us say, an exercise in which we are going to withdraw amount from one specific account object, so that code written for the withdraw activity will be inside the withdraw method, and the withdraw method will be a modifier method. Similarly, selector methods are those methods which are used to get the information or get the status of attributes or get the value of different attributes of that specific object. So this selector method is used to access the state of the object. About state of the object I will discuss little more. So next step is that once we are visualizing the objects, so different objects which are having common attribute and common services, they are grouped together and that particular is termed as class. So if we are having any class, so it should be very clear to us that if we are having class, we can generate or we can make instance of that particular class as per our requirement, and those different instances are nothing but different objects of that particular class type. Now once again, if we talk about student object, then student object may be one individual student object, but what is the basic representation of those student object, from where you are going to make those different instances? From the class, and that class is student class. So from that student class you can generate or you can make instance of several student objects, but one thing you have to remember, that all the student object which you are making instance of using a specific student class will be having the attributes and the operations or services which you have defined inside the class. So in the implementation stage or at the implementation level, when you are defining the class, basically you are making a structure on the basis of that different objects will be performing or different objects will be depicting the characteristics. So a class consists of objects. There are several objects. As per requirement you can make several objects, but all the objects will have what? Same interface. Same interface means all the objects of that specific class will be having access to the services which you have defined in the class and same attribute. So whatever field value or whatever attributes you have taken or defined in that particular class, that will be same for all the objects of that particular class. Obviously the value of the attribute will be different for different object as per your specific requirements. And again you can take one example of the student class. It may be there are several students. Let us say there is a class at your study center of 40 students. So all the 40 students are having their own specific attribute associated with them. They will be having their own name, they will be having their own specific roll number, they will be having their own specific contact addresses. So you see the value of those all different objects are different, but the name of the field is same for all. and the services or the activities which are expected from all the objects to perform is same. So, when we implement or write the code, then we try to visualize a class in two parts. One is the interface. Interface means the method which you are defining to provide different kind of services, and implementation means writing code for those different methods to perform the operation. Now, you can see this is the structure used to define class in C++ program. Then what you do, you write class keyword, then you write the name of the class, then your class starts, then you declare the attributes, and then you declare the interfaces or the methods. And one more thing is written there, that is that private, public and protected, these are the access specifiers. As you know, we are trying to protect our data or trying to restrict access of our data in object oriented programming. This is one of the important feature of object oriented programming, and that we do with the help of encapsulation. So, in encapsulation process, we try to hide the access of data directly to outside world. On the basis of the accessibility level, the data is provided to outside of the world depending on whether accessibility is private, public or protected. If accessibility is defined as private, that means that whatsoever is private, that is accessible within the class only. From outside of the class, you cannot access that particular specific attribute or interface or method. So, attribute and method cannot be accessed outside of the class if that particular attribute or method is private. Next is protected. Protected is having wider access permission, and that wider access permission goes up to that it can be accessed inside the class as well as it can be accessed by some other class which is derived from this particular class. So, when you are having plan of inheritance or you are having thought of that you will be inheriting features of one base class to some derived class, then if in base class you are having some data or some methods which you want to provide access to the derived class, and beyond that if you do not want, then it is better to make it protected so that you can use that particular data and method inside the base class, as well as accessibility of that you can extend to the derived class also. And public is most generic one, and this particular generic type of access is that it is open to all. Its visibility is to anybody. It is free. Means those data or those interfaces you have to make public that you do not want to have any kind of restriction, and it can be accessed by any object or by anybody even outside of the class in which you have declared and defined it. Instance variable, once again instance variable means the attributes which you have defined for a specific object. Now, here I have taken one very simple example of an object. That object is point. In geometry we know what is meaning of point. Point is having some coordinate value. In two-dimensional coordinate geometry if we are discussing about points, so it will be having value of x and y coordinate. So, if value of x and y coordinate are known to us, we can easily say that this is the point. We can pinpoint that particular location. So, if point is an object, then that particular object will be having two attributes. One is x coordinate and y coordinate. These two attributes will be there, and you can have several operations or several services on that particular point. If you are making a class, let us say point, in that you are defining two attributes x and y. These x and y are representing the x and y coordinate for a specific point object. So, method may be several. One method may be the display point, another method may be that shift point from one to another, third will be that move point from one location to another location. Many more operation whatsoever can be done on the point, that if you are getting another point object, so what is difference between 2 points, that also can be. So, you can thought of several operation on points that you have learned in your maybe 10th standard mathematics. So, take point as a object, and whatsoever can be done with different point objects, try to do that particular with writing simple programming exercises. So, here I have identified two instance variables x and y, that is x and y coordinate, and one operation, that is display point. It means if display point method I am calling, so I will be in position to display the location of that particular point. Now, state, let me discuss. What meaning of state of a specific object? So, if one object is at a moment and that particular object is having, let us say, certain value to their attributes or their attribute fields. So, on the basis of those values, that particular object is in a particular state at that particular moment. Now, one thing should be very clear to us. In object oriented programming, basically one game we are playing, and that particular game is that on the basis of changing the state of different object, we are trying to reach towards our solution. If you think object oriented programming in that way, that different objects are there, they are participating, they are doing different role in the system, and during that process the attribute value is changing of those specific objects, and those specific object changing attribute value may be your desired result. So, in the case of this point here, this is that you are having, let us say, value of x2 and value of y3. So, 2, 3 is a point object, and that particular 2, 3 is representing the current location of that particular point object. Similarly, if we are performing, let us say, shift in x direction. So, if we are adding some value to x coordinate, then the location of the point will change. So, once the value of that attribute of a specific object is changing, then state of that object is changing. It can be understood more clearly by seeing different examples, like if you are having account object, in that if you are doing some kind of deposit or withdrawal, the status of account object is supposed to change. And similarly many more. If a student object you are taking, it is more closer to you. If you are submitting assignment, your status is currently something different. If your assignment has been returned to you with marks, your status is something different. If you have appeared in your final examination, your status is something different, and it may be after result you will be registering in some other semester. So, the value of different field will be changing accordingly. So, it means objects are moved. Once we are performing different operation in our programming exercises, so our objects are definitely changing their states, and in that way contributing to getting the solution. So, every object has a state and a specific behavior. State of the object is defined by the value in its data member. So, whatever value is there, on the basis of that, at a specific moment of time, state of the object is defined. Each object must maintain its own copy of the space required for data member, because as we are saying as a basic philosophy that classification is representing different objects or group of objects. So, all the objects will be having their own independent existence, and that independent existence is only possible if they are maintaining their space separately. Behavior, which is specified by the functions, and it is same for all the objects of a specific class. Thus, only one copy of that particular function is kept, and that will serve the purpose. Little more detail you can find out in material, as well as if you want to go little more further, then you have to explore some reference books. In that you can go in little more detail that how actually in C++ programming compilation happen and what are the different copies of different things are provided, but this is beyond the scope of the syllabus. Syllabus is not containing those things in little more detail, but I will advise if you are having interest, you should explore that particular also to know more about that how actually once you are making different objects, what are the different copies of those things are created. That can be seen with the help of creating different objects, and finally your object file is created obj file, and see the size of that obj file, you will be in position to find that actually how much space your program is occupying. So this is a mechanism to find out. Otherwise, if you are not doing that, that is okay. Whatever is given in the material is actually part of your syllabus, but beyond that also you should go, because if you are looking forward to learn the C++ programming and object oriented programming, so this philosophy should be known to you. So all objects of accounts class, as we are discussing as example in this particular session also, and previous session also I have taken account class as a major example and we discussed in that. So if we are having, so all the account holder will be having their own specific attributes, and all the interfaces or all the operation of a specific account type will be same for all the account holder or all the account object. Now just go through this particular program and see. So here we are having a class point, there are two attributes x and y, and here we are having a constructor. For constructor I will talk little more in this particular example, and then we are having one method that is display. In display method we are displaying the value of x and y. So basically we are displaying the location of that particular point object, and in main method we are having 2 point object, one is the P1 and other is the P2, and we are displaying the value of P1 and P2. Now let me again come to the left side of the screen. So in this, if you see point, that point is a default constructor, and that particular default constructor is x is 0, y is 0. If we are not writing that particular code, in that case also the default constructor will do that only. As default constructor, assign the default value to the specific attribute of that particular object. Whatever attributes we are having, if we are not having any constructor defined, so by default whatever value of that data type of a specific field will be there, that is assigned. But if you want to have our own specific constructor, then that particular constructor we can define. If you see the second constructor, in that we have passed two arguments, int a, int b, and that particular int a and b is what? Int a and b are the two arguments, and these two arguments are representing the x and y coordinates. So we have assigned a to x and b to y, and then we are displaying the location at which that particular object is created. And by calling display method, we can call the location of that particular point object. Now, if you see on your screen, it is showing that how actually your program is running and what kind of method will be called and how they will be displaying the different information. So in the first, if you see, it is representing point is created and the value is 0, 0. Second point, P2, when you are creating P2, you are creating with the help of the constructor, that is parameterized constructor you are using. So on the basis of that parameterized constructor, two values you pass, 3 and 5, and then that particular will be displayed. And after that, in the last, we are displaying the location of object P1 and object P2. So point is at 0, 0 and the point is at 3, 5. So, that is being displayed. So, this is way of writing the constructors or creating the constructors. Now if here we try to understand little more that what is the actually need of constructor. So, constructor is a special program, as we discussed, that particular manager kind of method. So, the purpose of manager method is to initialize the object or to free the memory. So, for the purpose of initialization of the object, the constructor methods are called, and the constructor methods are special methods. Those methods are having name of the class itself. The method name here you see point, that point is the name of the class also. So, constructor methods are having name of the class, and then if you are passing the parameter, then that particular will be a parameterized constructor, and if you are not passing parameter, then it will not be the parameterized constructor. If you are not making any constructor, then by default the C++ environment create default constructor, and in that default constructor the value to the specific fields will be assigned as per default value or default value of that particular specific field type. Now, constructors are used to initialize the object data. A class can only be defined without specifying set of arguments, provided it either declare no constructor or it declare default constructor. Default constructor is invoked without passing the specific argument. So, whenever we are doing our exercises or creating program, so once we are going to use the object, so one thing should be clear to our mind, that once the object or once the instance of the class is created, that is your object, then what is the initial or default value of that particular object. So, if you are not providing initial value to that particular default object and you are not using any constructor to create that, so that particular object will be having the default data type value of those fields which are part of the attribute of that object. So, all the attribute will be having default value, but if you are making some parameterized constructor and you are specifically assigning the value to some specific field, so those specific fields will be having the value which you have passed as an argument to your constructor. So, use constructor, just you can do some exercises that create a student class and then try to pass different argument as parameter in your constructor and create the student object with those parameterized constructor. If you are not passing different argument, then see that what is the value of those specific fields which you have declared in your student class and how those particular fields has been assigned with the default value. Similarly, account class you take, similarly many other classes you can create and you can define different constructor, parameterized, non-parameterized. And one more thing here just I mention that once you learn the mechanism of method overloading we will be discussing little bit in this session. So, method overloading basically talk about that you are having same name but different argument. It means the function or the method name is same, but different arguments or different type of arguments are there, or different number of arguments are there in those different methods. So, it is a kind of overloading. Overloading means, by example we can understand that if suppose there is a class, let us say add, that particular add class is having some method to find out the sum of different values. It may be sum of two integers. So, if we are making a program or if we are writing a function sum, and in that we are passing two argument, that is two integer values, and those two integer values we are adding and returning the result. So, that particular is a one method. Similarly, it may be there is a method with three integer values. We are passing three integer value as argument and then we are adding those three integer values and returning. So that is another method, but the name is same, the sum. Similarly, it may be there is a method for sum and that particular is having one integer and one float value. So you see the method identification is happening on the basis of the type of argument or the number of argument in that particular method, and on the basis of that particular specific implementation will be called. So this is the concept of method overloading. Same name of the method but different prototype. And once we say that different prototype, it means that signature of that method is different than signature of another method. The only thing common in those methods is that they are having same name. And it provides basically a kind of common interface and common understanding, and it is extensively used to explain or to utilize the concept of polymorphism, that is static polymorphism. So constructors also can be overloaded, and constructor overloading means you can define more than one constructor for a specific class as per your requirement. It means if you need one object which is initialized with, let us say, only 3 attributes, if there are 5 attributes, only 3 you want to initialize. So with the 3 argument passing, you can initialize those 3 attributes or 3 fields, and remaining will be having default value. If you want only 2 to be initialized, then definitely you will pass 2 arguments and those 2 fields you will initialize. And similarly, as per your specific requirement, you can have different constructors for making the objects with different initial values or with different fields to be initialized as per a specific requirement. But remember that those fields which you are not providing any initial values will be having default value of their data type. This also you can do as an exercise, and you can write a small program to check that how actually constructor overloading is being performed and what are the different nitty-gritties of that. Now see one more example here. In this example, we have tried to create a class date, and this particular date class is having 3 attributes, and all the 3 attributes here we have declared private. It means within the class only it is accessible. If you try to access outside of the class, you cannot. Now see, one constructor we have defined, and this is a parameterized constructor. How many parameters we are passing in this constructor? 3. So these 3 parameters we have passed, and on the basis of that, a specific date object has been created, and after creating that particular date object, the name of the object here we have kept today. Today.display date will do what? Display date is a method inside the date class, and that particular method is displaying the value of 3 attributes. So we have created one object named today. The attribute value of that object is 20 for date, 4 for month, and 2020 for year. And once we run this program, we will get the result as you can see on your screen. So here we have created one object and we have displayed the value of that particular object, and we have demonstrated that how actually the constructor is defined and what is the meaning of parameterized constructor. In place of that, if I say that you create one more constructor with only 2 parameters, that is the date and month you will give, but year if you are not passing, then in that case date and month will be as per your specific value which you are passing, but year will be the default value of integer type, that is 0. Now let me move towards one important concept in object oriented programming, that is inheritance. Basically, inheritance provides us facility of using the existing program or existing program code to make our program covering more aspects or extendability. What is meaning of it? Meaning of it is that if we are having a program and in that particular program we are having certain code, and our requirement is that by using the current code, if we have to add something more in the system, then we can use the existing code and we can add some more functionality to it, or we can modify the existing functionality. Then this particular mechanism or this particular philosophy is known as inheritance. In inheritance, in another term we can say, if there is a class, existing class, that particular class can be used as a parent class, and on that particular parent class a child class can be derived, and the derived class is having right to access the code already implemented in the parent class and further extend on that particular code to make program more expandable or add more feature to it. So this is the meaning, reusing of the existing code, and derived class are developed from the base class by adding or altering the code of the base class. So if we are adding something more in the derived class, then definitely the existing program or existing feature will be extended. The developed new system will be having some more feature, or whatsoever implemented in the parent class, if that particular is modified at the derived class level as per specific requirement of the derived class, then we are altering the existing code of the parent class and we are making some other implementation in the derived class, but we are using some basic characteristics, some basic code of our parent class. This particular can happen. Now if we talk about inheritance, we have to think about one more question, that are there different type of inheritances? Obviously in C++ programming, if we talk about, we are having three main type of inheritance. One is single inheritance, it means from single parent we are deriving the child class. If there is a class A and we are deriving class B from class A, then it will be single inheritance. Multi-level inheritance, if there is a class A, we are deriving a class B from class A and deriving class C from class B, then class C is a more special class and it is having capability or it is having feature of class B as well as class A. So this is multi-level inheritance. And multiple inheritance, if there are multiple classes or parent classes existing and we are deriving from those multiple parent classes a derived class, then we say it is multiple inheritance. For example, if there is a class A and class B, and by using the features and programming code of class A and class B, we are deriving a class C, then the class C will be extracting the feature of multiple inheritance. So it is again the repetition of the same thing what we said. Inheritance is basically defining the class in terms of another class. One example here we can take, if we are having a student class, that student class will be having some specific attributes and features of an student, and similarly if using the basic student class we are going to make some specialized category of student class, that is the postgraduate student class, then the feature existing in the student class will be used and postgraduate student class will be adding some more feature. So postgraduate student class is now having more generic characteristic and more additional characteristic, and that generic characteristic is coming from the parent class and additional characteristic is coming from its own implementation. So it is expansion of the existing code. It is using some more feature which are already existing in the student class, then it is using that particular feature and then implementing some more thing in the PG student class. Similarly, some other Example we can take, we are talking about student class. So in that context there may be some other type of student class also. So for that particular type of student class you will derive, let us say, undergraduate student class, research scholar. Similarly, in another example we can see that there is a account class. From that particular account class we are deriving some special type of account class, let us say saving account class, current account class, fixed deposit. So these all are the different type of account class, and they are using the existing code of the account class. In addition to that, they are using or they are extending or writing some additional code to make that particular specialty to their specific requirement. Similarly, book, if we visualize book as a class, so from that particular basic book information, maybe author is there, maybe the ISBN number is there, maybe the publication year, some common feature or some generic feature we are keeping in the base class, and then our study material. We are deriving from that particular common feature to some special feature. So some common feature of all the books of all the different subject will be common, but on that particular commonality, if we are making some special kind of book for special kind of our specific purposes, then we will be adding to it, and it will be expanding further on the existing book class, and it will be deriving to another special book class. That special book class may be the study material, or it may be magazine, it may be some journal, it may be the articles collection, it may be poem, or anything that is having its own specialty, and once again it is having requirement in that particular problem solving context. Context is very important, because we see several things around us, but we take only those things which are required to our specific programming context. That is why it is very essential while we are learning the programming skill to have art of finding out that what actually required for our system. Only that must be choose, and only that must be implement in our system, so that the complexity of the system is also managed and unnecessary efforts we are not putting in our problem solving. And this is very important. That is why this art is very essential for us, and in that context identifying the attribute, identifying the different methods, and then deciding that which particular attribute will be visible to whom, means access level decision, and then implementation of the code, then how actually you are going to use this particular as a base class and going to derive some other class. So until unless you are having proper planning on your board, you will not be able to solve the complex problem or little complex problem. That is why you have to start from beginning, you have to write some small code, and then further you have to expand that particular by using these basic principles and mechanisms. Whatever I discuss here, these all things can be experimented, and these all things can be tested. And even in your examination also such kind of things are tested, or such kind of things are asked, that if you are having this, how actually you can inherit something from there and you can use it. So you must have to know the concept of inheritance. You must have to know the concept of what kind of access specifier and other things you have to use. So this is the mechanism through which we implement the inheritance. We write the class, then we give the colon, and then we use the access specifier operator. We choose whether it is public or private or protected. Basically, what level of accessibility in inheritance also we are going to define. So that particular we will discuss in little detail in the coming slide. When derived, we are deriving a class public, then public means the member of the base class become public to the derived class. So here in inheritance also, that public, private, protected is going to play a major role, and it is going to decide that the access of the code and access of the field of the parent class to the derived class is going to be controlled with the help of accessibility level specified. So it is very essential, and for that we are having here in this particular discussion, with the help of example, we will try to see that how actually accessibility is controlled. As if we are deriving a class using public specifier, then everything of the parent class become public member of the derived class. It means whatsoever public in the parent class, that is public in the derived class, and whatsoever protected in the parent class, that is protected in the derived class. But whatsoever private, that is private to the base class only, it is not open to the derived class also. So public is publicly available, protected become protected, and private cannot be accessed. Here in this particular table you can see it is more clearly written: accessibility, private, not inherited, protected. If it is public, means if there is a class B inheriting class A using public access specifier, then private is not inherited. It means private is private to the class A only. Protected of class A will be protected to class B also, and public of class A will be public to class B also. And if you are using protected, so whatsoever public there, that particular will be becoming protected in this particular derived class. It means in derived class, if we are using protected, so it is protected, and now it cannot be accessed to anybody. It is now protected at the level of B. So in the parent class, whatsoever is there, that particular accessibility to the derived class on the basis of access specifier used at the time of derivation is going to play major role. If it is publicly derived, then you see in the column private is private, protected is protected, and public is public. In private, if we are deriving private, then private is not inherited, protected become private, and public become private. It means from that particular derived class further things cannot be accessed. The things of the class A can be accessed up to class B only. Class B further cannot provide access of it to anybody else because it has derived privately. And similarly, if protected is there, so private is by default, it is private, it is not inherited. Protected become protected, and public also become protected. Now here also you can see once again private variable, accessibility from base class, obviously base class can access it. If we are having, let us say, 3 classes, A is base class, B is derived class, and C is a derived class from class B, then in that case this table can be interpreted as if from class A anything private we are trying to access, obviously private of class A is visible to class A, protected of class A is protected and it is visible to class A, and similarly public is visible to class A. Accessibility of derived class, not inherited, protected can be yes, and public can be yes. In which case? When we are doing public inheritance, and at the third level also you see the protected and public is accessible. So it is the most generic kind of accessibility at the time of inheritance, that public one. It means whatsoever is there, that is coming to the lower level of the hierarchy, and the derived class can access that particular thing. And next will give more clear picture. If class A is there, that particular class A definitely can access its own private, public, protected. Class B cannot access the private, it can access protected, but public also become protected here, because we are using the accessibility protected. In the heading you see accessibility in protected inheritance. It means class B is inheriting class A using protected access specifier. Then whatsoever public in class B that is available to class, whatsoever public to class A that is available to class B as public, but that particular will be becoming protected. In that particular second row and fourth column you see, second row fourth column is saying that if protected you are deriving, so that particular will be derived and it will be protected, but public if you are deriving, that particular also becoming protected to the derived class. And at the second level of accessibility, obviously that particular go on and it will be having access to public and protected in only, and obviously private cannot be inherited. In private case, if we are deriving class B from class A using private, then private will not be accessible, protected will be there, but that particular protected will become private, and similarly public also will become private. But at the third level of the hierarchy, for example, if from class B to class C we are going, then because we have derived using private access specifier, so at the level of B everything become private. So at the level of C nothing of the A can be accessed. This you can do with the help of a small exercise. Write a small program using, just make a class A, you have some public, private and protected variable, and just display that particular variable in class A. Similarly derive a class B using public, private, protected, and try to access those things as per the information given in table. So this also can form a very good exercise, and this particular exercise will clear so many doubts of accessibility and access level specifiers. Now here in this example you can see, if you see the code, in this we are having a class A. In that particular class A, just we are having a method, a body test. It is just simple name to show that we are inside the class A, and here I have used one scope resolution operator. So here I am introducing that double colon is treated or used as a scope resolution operator, and that particular scope resolution operator here we have used to define the method of the class outside of the class. If you see, the class has been declared and it is having only one public method, and that particular public method has been implemented outside of the class. Definition of that particular A body test has been done outside of the class with the help of scope resolution operator. This facility is there, and this reduce the complexity. Basically you can manage your programming little easily by using scope resolution operator. That is the purpose to demonstrate here the use of scope resolution operator. Otherwise I could have just simply implemented that particular A body method inside that. Now here see, we are deriving class B. B derived. What access specifier we are using? Public. A base. So we are deriving base class, A base class to B, and then we are using the body of the B. Now see how this particular program is going to demonstrate us or show us that how actually we are creating the object. Here we have created object, two object, one object, and we are calling that derived class object. The name of the object is objb. It is a derived class object, and now this derived class object is trying to access two methods. One is the parent class method, that is A body test, and other is the its own class method, that is B body test. So now here see, what advantage this particular program is showing to us? This is showing that the derived class is having capability now to access two methods. One is its parent method, that is a body test, and second is its own method. It means whatever we have implemented at a base class, that is already there, but if B derived class is inheriting a base class, then derived B class is now more richer with the whatever implementation in A base class is there, plus whatever implementation B derived class has done in its own implementation. So, reusability of the code we are doing, we have already used the code of the class, that is A base class, and then B derived class is having its own implementation, and it is rich with two methods, and those two methods are used here in your program. And if you run this program, you will get that particular result, that it is displaying that it is working in the method of its parent class as well as it is working in the method of its derived class. So, this is advantage. By using this particular advantage, you can use the existing code and you can derive the operations. Now, one question also arises that how actually constructors will be created. If we are creating derived class, then obviously the constructor of its base class also will be called in the derived class, because derived class is inheriting the features of its base class. So, demonstration of that particular is done here in your exercise here on the screen. You see there is a base class named base. In that particular there is a constructor, base default constructor message written here, just displaying a method. The purpose of this program is to show that how actually that particular constructor is called. And then next one is the derived class. So, in that particular derived class we are deriving the base class, and in this particular derived class also we are having its own constructor. Now, here we are having second constructor in the left side in the yellow color. In white color again we are having third constructor in the derived class, that is a parameterized constructor. Now, see here we have created in main method three objects. One is the base class object named B, two objects are derived classes. The D1 is the derived class, and that is the object created using default constructor, and D2 is a object created using the parameterized constructor. In that we are passing 50 as a parameter. Now, see we have created three objects. Now, our purpose is to test that how actually constructors are called in the base class object creation and derived class object creation. Can you guess what result you will get? Here you can obviously guess that base B will be calling its own constructor, so it will be displaying base default constructor method. But what about D1? D1 will be calling two constructor. One, first it will call the constructor of its base class, and then it will call the constructor of the derived class, and that particular derived class default constructor. And the third object, this also will be calling two constructor, one of its base class and second its derived class, that is the parameterized constructor, because we are calling that particular parameterized constructor by passing the parameter. Now, just see on the screen, you can see that how these constructors are called. So, it is showing that once you are making derived class or you are creating object of the derived class, you have to take care of the constructors also of the parent class as well as derived class. So, that should be properly synced, otherwise you will be having some kind of logical problem, or it may be that your object's initialization may face some difficulty. So, please take care that whenever you are making constructor or you are creating constructor, so how your parent class constructor will be behaving and how your derived class constructor will be behaving, that you have to check. and that you can check with the help of writing programs. Here once again I will repeat, repeatedly I mention in my sessions that writing program, exercise, doing the things. So without that it is very clear, no matter whatsoever you are learning, just by learning programming cannot be learned. So learning is not the method just by reading, you have to do. And here it is well said by Swami Vivekananda that 1 ounce of practice is much more than thousands of words. So in programming skill or programming context, it goes perfectly and it goes with full sincerity and dedication. So as a computer science student, do programming and programming only. And it is not necessary that all the time you are sitting on machine and doing the programming. Just make it as a habit that wherever you are, whatsoever you are doing, if you are having little bit time, and cycle stealing, you know that you have to try to do some kind of little bit cycle stealing, and in that process whenever you get little time, think about some problem, think about some logic to implement that particular problem and get solution, and definitely you will be learning more and you will be a better programmer and aspirations of yours will be met. So with this I conclude this session here, and before concluding this session, let me summarize very quickly. In this particular session I tried to explain you that how actually you are going to understand about object, how actually you are going to understand about how to create classes, define classes, and once you create the object, what will be the different data members of that object, and whatever the value of those data members that decide the state of the object, and interface will be common to all the objects of the specific class, or one class object, all the objects of one class will be having same interface. And in inheritance we try to learn that what is the advantage of inheritance, and if we are using different kind of access specifier in inheritance, then how actually we are controlling the access of the data member as well as member function of our parent class to the derived class as per specific access specifiers, whether it is public, private or protected. With this, thank you very much. Thanks for your patient watching the session. Thank you.